The next coming lectures will all be about volumes. I will show you how to run apps with stateful apps. And one of the demos is also going to show you how to run WordPress together with a database, because those are stateful applications. Volumes in Kubernetes allow you to store data outside the container. When a container stops, all data on the container itself is lost. That's why up until now I've been using most of the time stateless applications, apps that don't keep a local state, but can store their state in external service. With external service, I mean like a database, a caching server like MySQL, object storage like S3 can be used for that, NFS server can be used for that. You can all use those external services even without using volumes, because S3, you could code that in your app. A database you could run as a service. Now I'm going to show you a way to run those services inside your Kubernetes cluster. And then we're going to use volumes for that, and then we can run stateful applications. Persistent volumes in Kubernetes allow you to attach a volume to a container that will exist even when the container stops. So the container stops, the pod stops, but your volume can be reattached to a new container, and you can keep the state of your application. You can keep the files that are necessary for your application to run. Volumes can be attached using different volume plugins. Here you have an overview of the different plugins. On the left, we have our node with a couple of pods on, and the containers in the pod can then be used to attach a volume to. Let's say, for instance, pod 1 has a local volume attached to it, so that data can be saved on node 1 and then can be attached to another pod on the same node. The more interesting ones are the ones that don't exist on the node itself. Like if you're running on AWS, for instance, you can use EBS storage. You can attach this EBS to any node in the same AWS availability zone. Your node could completely die. You can spin up another node, or you can reuse another node, reattach an EBS volume to that, and then your pod can still be working. That's a big advantage of using these volume plugins that have storage outside your Kubernetes cluster. If you're running on Google Cloud, you can use Google Disk. If you're running on Microsoft Cloud, you can use Azure Disk. And then there are some other network storage providers that you can use that you might be even implement yourself, like NFS or Ceph. Those are a little bit more complicated because you might have to set up a Ceph cluster or an NFS cluster before you can then use those volume plugins. The one that I'm going to discuss is obviously the AWS EBS volume plugin, because we can use it on our AWS cluster. Using volumes, you could deploy applications with state on your cluster. Those applications need to read and write two files on the local file system that need to be persistent in time. You could run a MySQL database using persistent volumes, for instance, although this might not be ready for production yet. Volumes are new since the June 2016 release in Kubernetes, so depending when you're going to take this course, you might still want to be very careful about this. It will become stable at some point in time. Let me show you an AWS EBS example. If your node stops working, the pod can be rescheduled on another node, and the volume can be attached to the new node. So here we have node 1 and node 2. Node 2 doesn't have any pods. Node 1 has my app, and my app is using EBS storage. Let's say that node 1 completely disappears. Then what's going to happen is my app will be rescheduled on node 2, and then the container will link the EBS storage again, so that my app can access the data that was written on that storage that is in this EBS storage that is safe and outside the cluster. So this works, but only when those nodes are in the same availability zone. So let's have a look at the definitions that we need to use to create volumes. To use volumes, you need to create a volume first. In the next lecture, I'll show you how we can do this automatically, but now we are going to do this manually. So here I'm using the AWS tool to create a volume in US East 1 that is 10 GB of size. I'm also specifying the availability zone, which is US East 1A. And you need to note down this volume ID because this is what we are going to need later on. Next, we need to create a pod, or we can create a pod with a container. This is our container that we always use. We can specify volume mounts. The mount path can be /myvol, and the name is myVolume. So this name myVolume comes back under volumes. And then we're going to define AWS Elastic Block Storage, and we're going to specify the volume ID. And that's what I'm going to show you in the next demo.